the arc length of parametric curves. I'm going to walk you through how to do it really quick, and then we're going to do a quick example. Okay. So to find an arc length of a normal curve, let's say this was y equals fx, right? We know this equation, right? Root of 1 plus dy over dx squared dx. So in the case of a parametric curve, you obviously have y equals gt and x equals ft. And we already know how to find the gradient. So you can just put it dy over dt over dx over dt into here. And through some transformations, what you end up with is the integral from alpha to beta. Remember, you have to solve for the limits of the square root of dx over dt squared plus dy over dt squared dt. And you can get there using this. You simply take out the dx over dt squared and then do funny stuff to cancel out with the ft. So you guys can try doing that, but this is just the equation here, and we're going to be using this equation. And as a warning, when you use this equation blindly, it can lead to some mistakes because, for example, if you had a circle, but instead of being cos t and sine t, it was cos t and sine 2t. Well, that means that actually this circle is doubling on itself for every 2 pi. For every 2 pi, the circle is doubling on itself. And so what you end up with is, actually, if you use this equation, you're going to end up with 4 pi. But the actual arc length of the circle is only 2 pi. So you have to be mindful of that. The example is not going to have this, but just keep it in mind. Okay. So let's try doing an example. This is the same kind of the cycloid graph from before, but in this case, we're trying to find the length of one arch. So let's, I'm going to copy it over and let's try doing it. I think it's going to be interesting. Oops. Copy. Okay. So to find the length of one arch, that's what we're finding, and it's going to be from 0 to 2 pi r. Okay. So the equation to find something is the s of a parametric curve is from alpha to beta, a square root of dx over dt squared plus dy over dt all squared dt. I'm going to check, but when I do the test, I'm going to have a cheat sheet, so I can just use that. Okay, so let's find dx over dt and dy over dt, and then we're also going to find the limits. So dx over dt, differentiation of that is simply, let's write out the things, r times t minus r sine t. Okay, so the differentiation of this is just t minus r cos t. Okay. So what we end up with, so that's dx over dt. Let's do dy over dt, which is the differentiation of r1 minus cos t. So let's multiply that in. R1 minus cos t, r multiplied by 1 is r minus r cos t. Here. And the differentiation of that is r differentiates into nothing. Cos differentiates into minus sine, so it's just r sine t. Because the minus sign cancels out with the minus here. Let's just check our equations really quick. R minus r cos t and r sine t. Correct. Okay. Oops. That's why. RT differentiates into r. Okay. And so next what we have to do is find the limits. So when x is equal to 0, actually we found the limits before. Let's just reuse the limits if you've seen my previous video. Where is it? Okay. Yes. So the limit is going to be from 0 to 2 pi. So alpha is equal to 0 and beta is equal to 2 pi. So now the arc length is going to be from 0 to 2 pi of the square of, so dx over dt is r minus r cos t squared plus differentiation of r sine t all squared and dt. Okay, I just want to check really quick just to see if that's correct. So now let's expand the brackets inside. R minus r cos t is going to be r squared minus 2r squared cos t plus r squared cos squared t plus the right side is going to be r squared sine squared t. Okay, so already I see a cos squared t and sine squared t. It's going to be r squared of cos squared t plus sine squared t. That's going to be equal to 1, so this is simply just r squared. So let's rewrite the equation. It's going to be r squared minus 2r squared cos t plus r squared, because it's r squared times by 1. Okay. Square root of this, well, technically we can take r squared out. 1 minus 2r squared cos, oops, sorry. 1 minus 2 cos t plus 1. So that's going to be 2 minus 2 cos t. Square root of this, we can take r out. That's going to be r 2 cos t. Let's take root 2 out as well. So what we can do is we can take 2 of 1 minus cos t. And then we can take the root 2 out as well. Root 2 r square root of 1 minus cos t. Okay, perfect. And so now if we rewrite the equation, it's going to be root 2r from 0 to 2 pi of the square root of 1 minus cos t dt. Okay. And in this case, it might not be obvious, but what we have to do is find something that's squared so that we can get out of the square root, right? So we're gonna do let's use the double angle identity. Cos 2 theta is equal to 2 cos t minus 1. Okay, now let's arrange for this one, 2 cos theta. Sorry, 2 cos squared theta. Jesus. Okay, so we want to go from cos t to 2 cos squared theta. So what we're going to end up with is we're going to have 1 minus cos t is 2 theta. So therefore, if t is equal to 2 theta, then theta would be equal to t over 2. So 1 minus, and then whatever it is. So 2 minus, let's do this, minus cos squared t over 2 minus 1. And the minus minus, so that's going to end up with 1 plus 1, right? 1, let's just do it. 1 minus cos squared t over 2. And minus minus 1 is plus 1. So what we end up with is 2 minus 2 cos squared t over 2. That's going to be, let's take the root 2 out of this. Root 2 multiplied by 1 minus, let me just check. Oh, I see. So I think this is just, we can do it this way, but actually a quicker way to do this is if we did cos 2 theta equals 1 minus 2 sine squared theta. So yeah, sorry guys, I'm gonna do that because that's faster, but it actually works out through the Pythagoras thing, but let's just do this because it's faster. So cos t is cos 2 theta, t here is t half. So let's sub everything back in. Square root of 1 minus, and then cos 2 theta, so cos t is equal to 1 minus 2 sine squared t 1 half. This. So that's the square root of 1 minus 1 is 0, and then minus minus is positive, so it's just positive sine squared t over 2. So that takes, we can get the root 2 out. And then that's root 2 multiplied by root of sine squared t over 2. So let's rewrite everything. So now we have 2r, right? Because it was root 2 before, the root 2 multiplied by root 2. 2r of 0 to 2 pi, square root of sine squared t over 2 dt. Okay, now when we have a square root, a big thing that we have to worry about is modulus, because it could be positive and minus, right? Positive and minus sine squared t over 2. So we have to look at the kind of range that we're in. So what we end up here is 2r from 0 to 2 pi of modulus sine t over 2 dt. Okay, now to unpack this modulus, we have to look at the limits. And let me give you an example, right? For example, we had, instead of sine t over 2, we had modulus of sine t. Okay, if we look at the graph for sine t, and sine t is going to look like this. Okay, so from 0 to 2 pi, sine t will, from 0 to pi, sine t will be positive, and from pi to 2 pi, sine t would be negative. And look at the limits. It would be 0 to 2 pi, so from 0 to 2 pi. So we have to split this integral into 2. So if it was sine t, we would split this from 0 to pi of positive sine t plus from pi to 2 pi of negative sine t. That's how we do it. Plus. So that's how we do this. But because that's just an idea how to use modulus, but because we have t over 2, and the graph of sine t looks like this, so the highest limit is 2 pi, and 2 pi over 2 is just pi, and so for the whole range of this limit, it's going to be in the positive. We don't have to do the splitting up thing, but if we did have to, then we'd have to. So keep that in mind, guys. But this would just be a positive sine t over 2. Okay, and this would be simple, 2r, and the integral of sine t over 2, so that would be 2 cos, minus 2 cos t over 2 would differentiate into that. Let's just check. So when we differentiate this, cos turns into negative sign, so negative cancels out negative, leaves it positive, and 1/2 multiply out. Yep. So what we have here is 2r multiplied by, so the first one is 2 pi, so cos of pi is -1. So cos of pi is -1, so it's -2 multiplied by -1, because 2 pi over 2 is pi, and cos of pi is -1. And then we need to minus again, and minus of negative is plus, so let's plus 2 multiplied by 0, so cos 0 is 1. What we have is this. So what we end up with is 2r, and we have 2 plus 2, that's 4. So then we end up with 8r. There we go. And let's just check this answer really quick. I did this in class, 8r. There we go. So there you go. We found the length of one of the arches in this. Thank you guys so much for watching. Hopefully that was really helpful. Thank you guys.